Quadrilaterals, Section 3, Video 2. Here we're breaking down the properties of these quadrilaterals in just a little different way, just so we're clear on what quadrilaterals have certain properties and which ones don't. So this will be a great reference sheet for you to look at and think, how do I know each one of these properties is a part of these quadrilaterals, and how can I use them and when can I use them? So just to start, we'll start on the left side with opposite sides parallel. Well, that actually is a definition for some of these. I know that that's definitely part of being a parallelogram, definitely, and then we can check all of the parallelograms, since we know that that is part of the definition of a parallelogram. So we have a rhombus and a square. And then in a different color, I'm just going to write opposite sides. Both opposite sides aren't parallel for a trapezoid, but one of them is. So I'm just going to write one pair. And the same for an isosceles trapezoid. Opposite sides congruent, meaning that opposite sides are the same length. That is true for a parallelogram and true for all parallelograms. It's not necessarily true for a trapezoid, but for an isosceles trapezoid, we know that those two legs have to be the same length. So I'm going to write down here just the legs are congruent. And once again, not for a kite, because that's those consecutive sides, not opposite sides. Opposite angles congruent. We know that to be a property of parallelograms, so I can check all the parallelograms. Not necessarily for a trapezoid or isosceles trapezoid. For a kite, this one's a little tricky. Let me just draw it down here. If we have our kite here, where these two sides are congruent and these two are congruent. Now, opposite angles, it looks like they might kind of be. A great way to look at this is to break it in half like this and make that a right angle. And so if I think about this as a congruent triangles on the left and the right, I see that since we have a side-side-side relationship, I know that this angle and this angle have to be congruent. So there's one pair, but I don't necessarily know about the top angle and the bottom angle. I know that they're bisecting, but I don't know that they're the same. So I'm going to write here one pair again. And that's that left and that right that I drew in blue. Diagonals form two congruent triangles. I know that to be true from the properties of a parallelogram. So I'm going to mark all of the parallelograms. That's not necessarily true for a trapezoid. We don't know enough about trapezoids to know if the two triangles are congruent, or isosceles trapezoids. But we do know that for a kite, like I just drew, we know, I'll redraw it again, we know that if you draw a line straight down the middle, you can have side, side, side to prove that those two triangles are congruent. So I'm going to draw one diagonal will work. Because just to show, if I was going to do it the other way, if I was going to draw the diagonal this way, I don't necessarily know that those triangles are congruent because they have different side lengths. And so that's why I can't say anything about those, the angle up here or the angle down there. I don't know, and that's why I said there was only one pair of opposite angles congruent, and why there's only one diagonal that forms those two congruent triangles. For diagonals bisect each other, once again, that's a property of a parallelogram. So I'm going to mark all four. For a trapezoid, we don't know that, and for a kite, once again, diagonals don't necessarily bisect each other. diagonals are perpendicular, that was a property of a rhombus, which is therefore a property of a square. And we knew that because of those congruent sides is what makes that work to be a right angle. And we also know, like I drew over here with the kite, that our diagonals are going to be perpendicular as well. Diagonals are congruent. We know that to be a property of rectangles. And we also know that to be a property of squares. And it also works for an isosceles trapezoid, surprisingly enough. If I were to draw my isosceles trapezoid with the two parallel sides and then there's the true congruent sides here, I can kind of show this by drawing some congruent triangles here. It's a little messy, but I hope you can see that there's that blue triangle and that red triangle, and the diagonals are the ones that, cross right in the middle. And I know those are congruent because I have a side angle side relationship because of the properties of a isosceles trapezoid. So just to make it a little more clear, I know that this side is the same as this side. I know that this angle is going to be the same as this one over here, and I know they share this side. So that's why I know that those diagonals have to be congruent, because we have congruent triangles. Diagonals bisect its angle. That's a property of a rhombus that we have already in our notes, which is therefore, and that's also, therefore, a property of a square. And we also know that, like I said earlier with the kite, that with that one diagonal, that it bisects its angle. All angles are right. We know that only to be true for rectangles and squares. That one's pretty clear. And all sides congruent. We know that has to be part of the definition of a rhombus and a square. So those are some of the main properties we get for these quadrilaterals to show how they all relate, how their relationships between the different quadrilaterals, how they're different. So I encourage you to study this a little bit before you start on your homework. And good luck!